Hello and welcome to my channel Simon Rebello hashtag Scholastic Tutorials. Today we are going to study geometry for class 10. We are going to solve a pre-board exam paper. The first question: in triangle ABC, PQ is parallel to BC, and it has been said AP is 2, PB is 6, BC is 12. I got to find out PQ. Remember, in case if two lines are parallel, we get BPT or we get corresponding angle test. For BPT, my left hand side up down and my right hand side up down have been utilized. And for corresponding angle test, I will get APQ congruent to PBC and AQP congruent to QCB. Here, I will first take triangle 1 APQ and triangle ABC. Triangle APQ and triangle ABC and prove they are similar by a test called angle test. First of all, angle A is the common angle. A congruent to angle A, common angle. Then I'll get angle P congruent to B. That is corresponding angle test. Therefore, I get triangle A. I've named this as number 2 over here, and here this will be number 3. So angle APQ is similar to triangle ABC. APQ similar to triangle ABC. That is 1, 2, 3. That is by angle test. When I get this test, now I will get the corresponding sides, which states AP upon AB is equal to what? PQ upon BC equals to AQ upon AC. AP upon AB is equals to what? PQ upon BC, AQ upon equals to AQ upon AC. The value for AP is 2. I put that value for AP, and AB is 2 plus 6, that is 8. 2 plus 6. PQ is to be found and BC is 12. These two are not given, so I can cross multiply by taking these 4 and finding the answer. PQ will be now 3. My second question: find the side of a square. I have a square and I got to find the side if the diagonal is said to be 10 root 2 A, B, C, D. If I have a square, there are two possibilities. One is for the side and one is for the diagonal. Now they will tell me to find either the side if diagonal is given. Sometimes the side is given and the diagonal has to be found. The formula for side is equals to diagonal root 2. Diagonal upon root 2. Diagonal upon root 2. And if I have to find a diagonal, the diagonal is side root 2. Now here I have to find the side. Side means diagonal upon root 2, that is 10 root 2 upon root 2, where root 2 will be cut. My answer will be 10 units or centimeters whatsoever. Third question: if the arc of a circle which is neither a major arc nor a minor arc, then the measure of the arc is how much? If I have a circle, center O, A, this arc is AXB and this is arc AYB. This is the minor sector and this is the major sector, this portion. This is the minor sector here. This is minor arc and this arc is major arc. We have the length of the arc, we also have the measure of the arc. Now here we have been told to find the length of the arc which is neither minor nor major. So the possibility of the circle is in this shape. It has to be in this shape. A, X, B and this is Y. So this is minor semicircular arc on either side, and a circle is 180 degrees. So the semicircular arc, the measure of the arc of a circle is 360 degrees. So the semicircular arc will be 180 degrees, which is neither minor nor major. Now the next sum, if sec 25, sec theta is equal to 25 upon 7, find tan theta. Remember, in a right angle triangle, angle A is supposed to be theta from here, and this is 90 minus theta, sum of the angles. If I take this as theta, C will be 90 minus theta, because B was already given as 90 degrees. In a right angle triangle here, B is 90. If A is theta, then this will be 90 minus theta. Now sec theta is said to be 25 upon 7. Remember, sec theta is hypotenuse upon adjacent. So hypotenuse will be 25, adjacent will be, according to theta, 7. BC will be root of AC square minus AB square by Pythagoras theorem. Put the value for AC and AB. 625 square minus 7 square, that is 625 minus 49, will give me root of 576. Root 576 is 24 square. Square root gets cut, left is 24. So this side will now be 24. If I have to find tan theta means opposite upon adjacent. According to theta, opposite is BC and adjacent is AB. So BC is now 24 and adjacent is 7. 24 upon 7. There's another method for this. Solutions will be shown to you in the last. Because sec theta was given, so I'll take the identity formula which says sec square theta is equals to 1 plus tan square theta. So taking the square out and shifting it to the right hand side, sec theta is equal to what? So we have the value for sec theta, that is 25 upon 7 the whole square is equal to 1 plus tan square theta. Flip them, 1 plus tan square, left hand side to right hand side and right hand side to left hand side, is equal to 25 upon 7 the whole square. This will become 625 by 49. Taking 1 on the other side, I will get minus 1 over here. Now take the LCM. Take the square out. I will get here square root of 625 minus 576. Here we will take the LCM. LCM will be 49, so this is 625 minus 49 over here. So I will get here 625 minus 49 here. This will be 576 upon 49. That is 24 square upon 7 square. Taking square as common. 24 upon 7, the whole square. The square root will be cut off now. So answer will be 24 by 7. Next sum. Question 1b. We have a triangle A, B. Here AP is perpendicular to BC and angle A is 90 degrees. We are supposed to find write the names of the similar triangles by which theorem they are similar. We have one right angle triangle here, the big one. This is the second right angle triangle and this is the third. I take angle A as 1 or 2, you can say take A as 1, that is 90 degrees, so these two also will be 1. So in the first big right angle triangle, A is 1, B is 2 and C is 3. So in my second right angle triangle here, this was, because 90 degree was 1, so I put 1 over here. This was already 2, so this will become 3. Here 90 degrees is 1, 3 was already given, so this will become 2. Now arranging them, I will get, that is A, B, C similar to, go to number 2 here, second triangle, PBA, triangle PBA, and the third 1, 2, 3, that is same way, in the same order. I will get here PAC. These two triangles are similar by angle test, and here these two triangles are also similar by angle test for similarity. When ABC is similar to PBA and PBA is similar to PAC, therefore ABC is similar to PAC. So here all three triangles will be similar by angle test. We come to the next sum. P is supposed to be the midpoint of segment AB. Here I have a segment AB. P is the midpoint. A is 2, 4, minus 4. B is minus 6, 2. I name them as x1, y1, x2, y2. Find the coordinates of point P, that is x and y. I got to find these two coordinates. Here I will find the x coordinate and here I will find the y coordinate. Now the formula for x coordinate, if I have got P is the midpoint, that is by midpoint formula, it says x is equals to x1 plus x2 the whole upon 2. x1 is 2 plus minus 6 the whole upon 2. 2 minus 6 will give me minus 4 by 2 will give me minus 2. Now if I have to find y coordinate, y is equals to y1 plus y2 the whole upon 2. y1 is minus 4 plus y2 is 2 the whole upon 2, minus 4 plus 2 the upon 2, that is minus 2 upon 2 will give me minus 1. So the y coordinate will be minus 1. Next sum. If question 1b, sum number 3, if sine theta equals to 20 by 29 and cos theta is equal to 21 by 29, I have to find tan theta. Formula for tan theta is sine theta upon cos theta. This is one of the trigonometric ratio here. Put the value for sine theta 20 upon 29, cos theta is 21 upon 29, 20 upon 29, inverse this into 29 upon 21, 29 gets cut, 20 upon 21. So answer for tan theta is 20 by 21, 20 upon 21. Solutions will be provided to you in the last, handwritten. You can take the screenshots and solve. The length of an arc of a circle is 3.5. I have a circle, the length of an arc, name it as AXB. I told you this side will take as length and here will take as theta. Length will be in centimeters and here theta will be in degrees. Length can be in centimeters, meters, anything. Now it is said length of an arc is 3.5 centimeter. Radius is 2.2. Find the area of sector. Radius is 2.2. These both thetas are same because this is central angle. I got to find the area of the sector. The area of the sector is here. Area of sector is, there are two formulas. If I have length, the formula is area is equal to half length into radius. Area formula is half length into radius, and here if theta is given, area is equal to theta upon 360 into pi r square. Since theta was not given to us, so we will take this formula. Area is equal to half length into radius. Put the value for length, that is 3.5, and radius is 2.2. Multiply them with half. You solve it, remove the point, you get 10 down. Finally, your answer will be 3.85 centimeter square. The area of sector, that is sector is O dash AXB, that is minor sector. Area of sector is 3.85 centimeter square. The next sum. Question 2a. Complete the following activity. Now we have got a diagram over here. 3 parallel lines with 2 transversals here. Remember, property on 3 parallel lines is here. Now this name is line L, is line M, ACE, ACE, B, D, F. These lines are parallel. If lines are parallel, then I get AC upon CE is equal to BD upon DF. So the formula will be AC upon C is equal to what? BD upon DF. AC is said to be 5.4, C is 9, BD is 7.5. We got to find DF. Cross multiply and the value for DF will be 12.5. Okay, the next question. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Prove the theorem, draw the diagram and write the points. Now, here is a circle. The 4 points touching the circle form a cyclic quadrilateral. Name it as A, B, C, D. This angle is the exterior angle. I name it as E. I have to prove angle CBE is congruent to angle ADC. I'll give you the explanation over here. Very first thing, this is to be proved. Angle CBE plus angle CBA is equal to 180 degrees. The reason is angles forming linear pair. Now in a cyclic quadrilateral, angle CBA and angle CDA, they both form 180 degrees. So angle CDA plus angle CBA is equals to 180 degrees. Opposite angles of cyclic quadrilateral are supplementary. Because my right hand side is same, my left hand side will be same. So I will write here angle CBE plus angle CBA is equals to angle CDA plus angle CBA. Cut CBA on either side. Left is CBA equals to CDA, which has to be proved. That is CD and ADC are same. Hence proved. Next sum, the measure of the central angle of a circle is 150. Question says the measure of the central angle is here, and in this as AXB by central angle is 150 and radius is 21. Find the length of the arc. Told you, in a circle we'll have a length and here we'll have a theta. There are two formulas. If I have got length, area is equals to half into length into radius, and here area is equals to theta upon 360 into pi r square. Half into length is not given, into radius 21. So I'll get here area is equal to what? 10.5 L, and here area is equal to theta is 150 upon 360 into pi r square, that take it as 22 upon 7, and radius 21 square here. Now the areas are equal, so the answers should also be equal. I will then cross multiply and I will get the answer. Length is equals to 55 centimeters. Another way, you can say the ratio of theta upon 360 is equals to length upon circumference, that is 2 pi r. Put the values over here. 150 upon 360 is equal to, length is how much? Unknown. 2 into 22 upon 7, radius is 21. Cross multiply and you'll get length is equal to 55 centimeters. Solution will be provided to you all in the last for each and every sum. Next sum. If the sides of a triangle, are 8, 15 and 17 respectively, determine whether triangle is a right angle triangle or not. For a right angle triangle, the hypotenuse will be the biggest side, that could be a 17, 8 and 15. So we got to first check by taking 8 square. 8 square is 64, 15 square is 225, 17 square is 289. If I add these two, keeping this as hypotenuse according to Pythagoras theorem, the sum of the squares of the other two sides is equal to the sum of to the third square of the third side. Hence, the triangle is a right angle triangle. So we have to write down there, if the square of the greater side is equal to the sum of the squares of the other two sides, then it represents a right angle triangle by Pythagoras theorem, and the three sides are Pythagorean triplets. Next sum. Angles made by a line with positive direction of x-axis. This is the x-axis and this is the y-axis. Is 60. Define the slope of these lines. There's the line here. The angles are one angle is 60 degrees and another one is 45 degrees. Formula for slope. Slope of this line L and slope of line M. Slope is represented as M. Slope of the line is tan theta, which is equal to tan 60 degrees. Tan 60 is in the table root 3. So slope is root 3. And for the other line, slope, it is M. This is for line L. And now we'll take for line M. Tan theta tan theta is tan 45. Tan 45 is 1. Next question. Simplify. Sec theta plus tan theta into 1 minus sin theta. Trigonometric sum. Convert all into sin and cos. Sec theta means 1 upon cos theta plus tan theta means sin theta upon cos theta. Here I'll get 1 minus sin theta as it is. Taking the LCM here, I'll get cos theta 1 plus sin theta into 1 minus sin theta. 1 plus sin theta into 1 minus sin theta upon cos theta. 1 plus sin theta into 1 minus sin theta is a plus b into a minus, that is a square minus b square upon cos theta. 1 square is 1 minus sin square theta, the whole upon cos theta. 1 minus sin square theta is the identity formula which says it is cos square theta upon cos theta. Cos theta and square will get cut, left is cos theta. So the answer is cos theta. Next question. Find the slope of a line passing through the points A and B. I have got 2 points here, A and B. A is minus 3 comma 5 and B is 4 comma minus 1. This is x1, y1, x2, y2. I got to find the slope of this line. Slope of line, slope means m, which is already been said, it is as tan theta, but here now theta is not given. So we'll take the coordinates y2 minus y1 upon x2 minus x1. Formula is here for the slope. So y2 will be minus 1 minus 5 upon the whole upon 4 minus minus 3. That will give me minus 1 minus 5 upon 4 plus 3 minus 6 upon 7. Next sum. Find the surface area of a sphere of radius 2.8. This is a sphere. Radius is 2.8 centimeters. I got to find the surface area. Now first, for a sphere, the curved surface and the total surface area formula is the same. 4 pi r square. Put the values. For pi is 22 upon 7 and the radius is 2.8 the whole square. 4 into 22 upon 7 into 28 upon 10 into 28 upon 10. You solve this and you'll get 98.56 centimeter square. Next sum. It's an activity. Triangle is given. C, A, M, B. This is the median. Now median means this could be the midpoint and these two sides are equal over here. Activity says M is the midpoint of segment AB and segment CM is the median of triangle ABC. Now area of triangle AMC upon area of triangle BMC. Area of triangle AMC and area of triangle BMC both have a common vertex, so the area should be equal. Sorry, their height should be equal and area should be proportional to the corresponding bases. So here I'll have formula is B1 into H1 upon B2 into H2. Base 1 for AMC is AM and for BMC it is BM. Both the heights are same because they have a common vertex, so I can cut them here. So the answer will be over here AM upon BM, but AM upon BM, since this is a median, will get cut 1 upon 1. Therefore finally I'll get area of triangle AMC is equal to cross multiply to area of triangle BMC. These two triangles areas are equal. because their heights are same and their bases are congruent. Next question. Activity 2. There is a triangle L M N. LP is perpendicular to MN. Another triangle is here. DQ perpendicular to MN. Activity says area of triangle LMN upon area of triangle DMN is equals to dash. Now LMN and DMN both have a common base, so area should be LMN and DMN. Areas are proportional to the product of base into height. Correct? So bases are same, I can cut them. So areas are proportional to heights H1 and H2. That is LMN ka is LP upon DQ. Next sum. Segment D segment DE is a chord of a circle with center C. Segment D is a chord of a circle with center C. CF is perpendicular to DE. Now if this is perpendicular, then these two sides will be equal. Perpendicular from the center to the chord bisects the chord. Diameter of circle is 20. Find CF. Okay, and D is how much? D is said to be 16. It's a circle, center C, D is 16, and diameter here, L limit as A, DA, diameter is 20. Remember, we have to go to this right angle triangle. First I'll say CF is perpendicular to DE. Once I get perpendicular, I can use Pythagoras theorem. So I'll say CF square is equals to CD square minus DF square by Pythagoras theorem. Now CF is to be found is equal to square root of CD square minus DF square. Take the square to the right hand side to become square root. Now CD is how much? Half of DA, that is the diameter, minus DF is how much? DF is half of DE. This is property of diameter. Radius is half the diameter, and this is perpendicular drawn from the center of the circle to the chord, bisect the chord. Put the values over here. Half DA will give me 10 square, that is 100, minus half DE will give me half into 16, that is 8 square, that will give me 64, 100 minus 64 will give me root of 36. That is 6 square. Square it goes out. So left is 6. So CF will be 6. Next sum. Adjacent sides of a parallelogram are 11 and 17. If the length of one of the diagonal is 26 centimeters, then find the length of the other diagonal. Here I have a parallelogram A, B, C, D. Adjacent sides 11 and 17. The diagonals of a parallelogram bisect each other. We take this as O. One of the diagonal is 26. Immediately. These both sides are congruent. These both sides are congruent. Diagonals bisect each other. I have to find the other diagonal. Now, first of all, this quadrilateral is a parallelogram. Secondly, AC and BD bisect each other at point O. Now in triangle ABD, AO is the median. AO is the median. In triangle I said ABD. Now I will get here AB square plus AD square is equal to twice BO square plus twice AO square plus twice BO square by Apollonius theorem. AB is 17, AD is 11, AO is not known, BO is half of 26, 26. Solve this, this will become 289 plus 121 is equal to twice AO square plus 2 times 13 square, that is 169. 169 into 2 will give me 169 into 2 will give me 338. Now this will become 410. 410 is equal to twice AO square plus 338. 410 minus 338 is equal to AO square, twice AO square. 72 upon 2 is equal to AO square. 36 is equal to AO square. Root of 36 is equal to AO 6 is equal to AO square root will get cut here. AO is equal to 6. I get AO as 6. Therefore AC will be now twice of AO. AC is equal to what? Twice AO, which is equal to 12 centimeters. Next sum. Circle is given. There is a tangent here. The triangle inscribed. D F A B C S Q. DQA is 84. Measure arc DQA is 84. Measure arc FSA is 150. Then find the value of DAB. And FDA. See, very first thing, this is a tangent, this is a secant. Here, this is an inscribed angle. Angle ADF is inscribed in the arc ADF, and this is the intercepted arc. So obviously, if this is 150, this will be 75 degrees by inscribed angle theorem. And this is a tangent, this is a secant, so this will be half of 84, that will be 42. Here this is twice of FDA, so this arc will be 150. Here, sorry, this was given as 150, so this angle will be half, that is inscribed angle. Next, draw a circle with radius 3.5. Draw a chord AB of length 5.7. centimeters. Construct tangents at point A and B without using the center of the circle. So here I got to draw tangents, and where they meet could be the point P or T without using the center. So I cannot take the radius. Now to construct this, I have to first draw a circle of radius 3.5. Then take your compass, keep it here at any one point, mark an arc 5.7 centimeters A, B. Take any point on the circle as C. Make it a triangle by joining these 2 points. Now take your compass here. At this point this will be 0. Draw an arc. This is 1, this is 2. Keep it here 0. That same measure of the arc. I get 1. Now I don't get a 2 over here, not here. So I will take the measure of 1, 2 over here, and I will get this as 3. So this measure of 1, 2 ka, I'll keep here 1 and I'll cut here. So I get here 3. This is my 1 tangent. Take the same 0, 1, 2, 3 ka. This is my 0. That 1, 2 arc. I write here 1. And this as 2. Or take this as 1 and this as 2. Anything will do. Now 1, 2 ka jo measure was there. This 1, 3 ka. Oh, I'm sorry. This is 0. This is my 1. Take the measure of 3 over here. This is my tangent. Line L, line M. Let them meet at point T. AT is equals to BT. You got to find out what is the measure if you want to, and write down here. Tangents drawn from external point are congruent. Next, from the top of a building, here is a building AB, and there's a scooter here, point C. Scooter, this is the building. An observer is looking at a scooter parked at some distance away, making an angle of depression of 30 degrees. Now observer is here, standing on top. Here is the horizon. I'll keep this as X. I'll name it this as horizon here. Makes an angle of depression . So this particular angle with the horizon is theta. This will also be theta over here. This theta is, angle of depression is 30 degrees. If this is 30, this will also be 30 because they form alternate angles. From the top of a building, an observer is looking at a scooter parked at some distance away, making an angle of depression of 30 degrees. If the height of the building is 40, now this is supposed to be 40, how far is the scooter from the building? We will now take 10C, that is opposite upon adjacent. I can even take cot C, adjacent upon opposite. 10C says it is opposite upon adjacent. 40 upon opposite is BAB upon BC. 40 upon BC. Then C is 1030, which is 1 upon root 3 is equal to 40 upon BC. Cross multiply and you will get BC is equals to 40 root 3, that is 40 into 1.73, that will give me 69.20 meters. Now if they ask you how far is the observer from the scooter, take the value of BC over here and AB, and by Pythagoras you can find this, or else you can take sin theta opposite upon hypotenuse, so you will get a hypotenuse length. You can also take cosec theta hypotenuse upon adjacent, that is, now theta is 30, put the value and find. Next sum. Here is a circle, so diameter A, O, B, C, Q, Y, X, P. ABC is a right angle triangle. At B, a circle is drawn with diameter AB intersecting the hypotenuse at P, show that the tangent to the circle at P bisects BC. Then I have to show that these both sides are equal. Construction join BP. Now if I take this as X, BAC, then this arc will be 2x. This is called inscribe angle theorem, and this is the intercepted arc. This is a diameter, so this angle will be 90 degrees. Diameter subtends right angle on the circle. If this is 90, this will be 90 over here. Adjacent angles forming linear pair. Now this is 90, this is x, this is 2x. This is a tangent. And this is a secant here. So if this arc is 2x, this angle will be x by tangent secant theorem. Here this two tangents are congruent. Tangents drawn from external point are congruent. Now this will become 90 minus x. Adjacent angle of BPQ. If this is x, this will be 90 minus x. In the big triangle this was x, this is 90, so this will be 90 minus x. Sum of angles of a triangle. These two angles are congruent in PQC, so these two sides should be congruent. Base angles are congruent, then the corresponding sides are also congruent. Converse of isosceles triangle theorem. Now here initially I got BQ equal to PQ, and now I got QC equals to PQ. In either case I got PQ and PQ congruent here, so I'll get now BQ is equals to QC. How to prove it? I will write and show you the proof. Next, there's a right angle triangle BAC. O is the center of the semicircle. Triangle ABC is a right angle triangle. Side AB and side BC touch the sides of the touch the semicircle at point D and E. OA is equal to 15 and OC is equal to 20. Find the radius of the semicircle. Construction join DO. If you want, you can join OE also. Now this is the radius here. This is a tangent because touching, this is a point of contact. OD is perpendicular to AB. AB is perpendicular to BC, that is 90 degrees, and OE is perpendicular to BC. So 3 places we get 90 degrees. In triangle DAO and triangle BAC, this is 1, 2, with the big triangle and small triangle common angle, so this will be 3, 1, 2, so this is 3. Now here I have got two triangles similar, triangle DAO similar to triangle DAO is similar to triangle BAC. My angle test. Then I'll take the ratios of the sides DA upon BA, DA upon BA is equal to what? AO upon AC is equal to what? DO upon BC. Next, take triangle DAO and triangle DAO and triangle EOC. D is congruent to E, each angle is 90 degrees. A will be congruent to O, corresponding angles, because these two lines are parallel, so these two angles will be corresponding angles, therefore these two triangles will be similar. My angle test. Now take the values of DA upon EO is equals to AO upon OC equals to DO upon OC. Put the values for each. EO is the radius, so DA upon R 15 upon 20, DA upon R is equal to 15 upon 20 AO upon OC, and this will be as it is. This will be DO is again radius over here, R upon OC. Now DA will be 3 upon 4 R, cross multiply taking these 4 terms, 3 upon 4 R. Now go to triangle DAO. Next step, go to triangle DAO, right angle triangle, and try to find out DA. Back again, because we have already got DA. DA is equal to what? 3/4 R. Now in right angle I will get DA is what? AO square. DA is equal to AO square minus OD square, DO square. And here root will come over here by Pythagoras theorem. DA are same. So 3/4 R is equals to root of AO square minus DO square. AO is 15 and DO is R. 15 square minus R square. Put the values, cross multiply, bring square root over here, and I'll get R equals to 12 centimeters. Solving will be shown to you. Next sum. Draw a right angle triangle. Draw a triangle ABC. A right angle triangle in which AB is 3, BC is 4 and B is 90. So my right angle triangle, I'll draw it this way now. B is 90, ABC, in which AB is 3, BC is 4, B is 90. Draw segment BD perpendicular to hypotenuse AC. Draw a circle through points BCD. Construct tangent from point A to this measure and write the length of the tangent segments. I got to draw a circle over here consisting of BDC, and from point A I got to draw tangent. One tangent is already here, another one should come from here. The first step, first take segment BC 4 cm and take angle B as 90 degrees. Then arc BA 3 cm. Triangle ABC is ready. From point B, draw perpendicular. Taking measures of this arc, I get a perpendicular here. This is D. Now take BC, diameter, draw perpendicular segment bisector. From this point O, I will draw a circle. This shows diameter, substance right angle, so this will become a circle now, and I'll have point BDC lying on the circle. Now AB is a tangent, and tangent drawn from external point. Taking this measure, I'll draw an arc over here, and join this, I get another tangent, that is AE. Next, point A 1, -2, point B 5, 2, point C 3, -1, point D -1, -5 are the any 4 points. Frame one mathematically correct question using all 4 points and solve it. Now I've got point A, point B, point C and point D. 1, -2, 5, 2, 3, -1, -1, -5, A, B, C, D. First find distance AB, distance BC, distance CD and distance DA. Distance AB, y2 minus y1 the whole square plus x2 minus x1 the whole square. Put a formula for distance formula and you will get AB as 4√2. Similarly, you will get distance BC as √13. Then I'll get distance CD as 4√2. Distance DA √13. So condition 1 and condition 3, 2, and here this is 4. So 1 and 3 are same, which says, and 2 and 4 are same. The opposite sides are congruent. Because opposite sides of the quadrilateral are congruent, therefore the quadrilateral is a parallelogram. Now the question what I have to frame is, prove that points A 1, -2, B 5, 2, C 3, -1, D -1, -5 are the vertices of a parallelogram. So very first we'll take distance AB, BC, CD, DA. And when I get AB equal to CD and BC equal to DA, my question will be, prove that A, B, C, D are the vertices of a parallelogram. Because opposite sides are equal, therefore the quadrilateral is a parallelogram. Next, a juice seller was serving his customers using glass as shown in the figure. glass is so thick. A juice seller was serving his customers using glasses as shown in the figure. The inner diameter of the cylindrical glass was 5 centimeter. Now this diameter is 5 centimeter. But the bottom of the glass had a hemispherical raised portion, that is here a hemisphere, which reduced the capacity of the glass. If the height of the glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. Now, first of all, we will find volume of inner capacity of glass. That is, it's a cylindrical form, so pi r square h. Pi is 3.14, which is given to us, and radius will be half of diameter, that is diameter upon 2 the whole square, and height is 10. Solving this, I'll get 196.25 centimeter cube. That is the inner capacity of glass. Now volume of inner hemisphere, that is this hemisphere, is 2 upon 3 pi r cube. Pi is 3.14 and diameter is half of diameter is radius is diameter upon 2, that is 10 upon 2, 5 cube. Sorry, not 10 upon 2, 5 upon 2. 2 upon 3 into 3.14. The diameter was 5. So here it will become 5 upon 2, the whole cube. Solving this, I'll get 3.27 centimeter cube. Now the apparent capacity will be volume of apparent capacity of the glass is volume of inner capacity minus the hemisphere. Volume of inner capacity of glass minus volume of hemisphere of the glass, inner hemisphere. That will give me 196.25 minus 3.27, that is 192.98 centimeter cube. Please like, share, give a thumbs up. This will help you out. Now next we are going to see the sums, how they are being solved. Explanation was given to you all. Just copy them as they are.